I'm Pam Murray-Tuite. I'm a professor of civil engineering at Clemson. I'm also the lead of our project 1.3, which is called the Command and Control, particularly called the multi-scale team routing for autonomous ground vehicles in unstructured environments. Our objective is to determine the team composition and sizing, along with routing and physics-based control for a group of autonomous ground vehicles that are operating in an unstructured environment.
I'm Matthias Schmid. I am a research associate professor in the Department of Automotive Engineering at Clemson University. And within the VIPR-GS Center, I serve as the investigator in a various of different projects, namely the focus area 1.3, this is command and control, as well as the Deep Orange project, and a few of the new projects we started this year. What does it mean to do dynamics estimation and control in VIPR-GS? Our work actually encompasses a wide range of focus or efforts ranging from fundamental algorithmic development to model building to actual experimental validation and verification of our approaches.
Due to the absence of formal road networks in off-road environments, some of the other things like soil properties and the ability of the soil to hold the vehicles and even the vehicle's capabilities come into play. So we take into account the environment properties and the vehicle's capabilities to generate our global paths and make sure that the vehicles that we plan for are able to follow those paths. Since we are working on the global path planning, this can be useful for the Deep Orange vehicle for generating the initial plan on the environments that it is going to run on.
Initial planning happens on a high level that cannot take the individual dynamics and capabilities for vehicles in a potentially heterogeneous fleet and in different environment conditions. Therefore, only waypoints are produced at the higher planning level. These waypoints now need to be translated in a computationally efficient manner into feasible trajectories for individual vehicles. Our preliminary results do not only allow to solve this task of feasible trajectory generation in negligible computation time, but also have been used to improve high-level planning tasks.
The focus of my work lies on physics-based models. The idea is to develop models that are of suitable fidelity, that they can inform controllers and to predict the performance of these vehicles, especially skid-steered vehicles, in real time. So a prior version of these models has already been used to design the Deep Orange vehicle, to design the powertrain requirements for this vehicle that we have constructed, and the subsequently manufactured prototype and the data we've collected from that vehicle has allowed us to improve the model and fit the model to the actual performance of the real vehicle as it is. Now, this model that we've newly created has allowed other VIPR-GS researchers in their digital twin efforts in improving their understanding of the vehicle we have and improving their digital twins for these vehicles.
For this project, I have been working on establishing an control architecture for the military operations that we are focusing on. These operations can incorporate fleets of vehicles, and in such cases, we not only need coordination amongst vehicles, however, also vehicle control for completing the mission itself. My work has been focused on decomposing these control tasks into formation control aspects as well as local control for trajectory tracking. While we have validated this framework in simulations, I'm very excited to apply this control framework to the physical prototypes that we are developing as part of the VIPR-GS Center here in Clemson, and validate the performance of the control algorithm.
Our focus on off-road domains, on uncertain, unstructured and friendly environment is a niche which makes us unique And the project demonstrates in a perfect way how we can work together with different disciplines, different student groups at their different career stages, be it master or PhD students, with the hardware we have available, with the capabilities we have available, not only at Clemson, but through the VIPR Center to arrive at really impressive results.
Our center is really exciting. It covers so many different aspects of the autonomy section, and well as we're also working with some of the projects in Focus Area 3, which is also pretty exciting because it gives us a chance to really test out our algorithms in a digital setting as well as a real-world setting. And so this is a really unique opportunity, and we're very excited for the potential for our algorithms to be incorporated into the real world.